In this video, we're going to start our discussion on concentration. So in order to define a solution precisely, we have to state its concentration, which is the amount of solute that's dissolved in a certain amount of solvent. So sort of similar to that saline solution we talked about, where there were 9 grams of sodium chloride for every 1 liter of water. So there are several ways that we can express concentration. We have percent composition and molarity, but within percent composition, we could talk about the mass of a solute per mass of solvent, or the volume of the solute per volume of solvent, or we could talk about the mass of solute for every volume of solvent. So it just depends on whether we have, for example, solids, liquids, or a mixture of a solid in a liquid. Now, molarity is going to be a little bit different. We do use molarity the most often in chemistry, and this has units of moles of solute per liter of solvent. But we'll get into that in the next video. So let's look at the first type of percent composition, which is mass per mass. So this is defined as the mass of a solute divided by the mass of a solution times 100. So I have the equation down below where percent of mass per mass is equal to the mass of the solute over the mass of the solution times 100. Now notice that the mass of the solution is actually equal to the mass of the solute plus the mass of the solvent. So the total mass of everything together. So let's do an example problem where we calculate this percent composition. Oops. So let's say we have a saline solution with a mass of 355 grams. So it sounds like that's the total mass of the solution. So let's write that down. And then we're told that this solution has 36.5 grams of sodium chloride dissolved in it. So that is the mass of the solute. Now, how did I know that sodium chloride was the solute? Well, remember that the solute is the substance that's in a smaller amount. Now, we want to figure out what is the mass percent concentration of the solution. So we're just going to plug those values in to the equation up above. So we've got 36.5 grams of solute divided by our total mass of 355 grams. And then we'll multiply by 100. So notice that the units of grams cancel. So this is going to be a unitless number, or a percent. And when I plug this into my calculator, I get a value of 10.3%. So what does that mean? So this tells us that 10.3% of the solution is sodium chloride, and the rest will be presumably water, right? Since it's a saline solution. Okay, we're actually going to skip this next problem. We're just going to go on to percent composition volume per volume. So this is going to be exactly the same as our last equation, except instead of masses, we're going to use volume. So for gases and liquids, volumes are relatively easy to measure, and that's why we can express our concentration of a liquid or a gas in this particular way. So this percent composition is the volume of a solute divided by the volume of a solution times 100. So the equation is shown below. And again, notice that the volume of solution is equal to the volume of solute plus the volume of the solvent. So this will be our total volume of everything together. So let's do a practice problem. Let's say we have an 8.4% solution of methanol in water, and it has a total volume of 450 milliliters. What is the volume of the solute, methanol? Okay, so it looks like we're actually given this value, the percent volume per volume. And, oops, let me fix that. There we go. So that's 8.4. And then we're also given the total volume. So the volume of solution, which is 450 milliliters. And we want to figure out what is the volume of the solute. So we're trying to solve for this top portion of the equation. Okay, so let's plug in what we have. So we've got, I'm actually going to erase and make a little more room here. So we've got 8.4 is equal to, and then we don't know the volume of the solute. So I'll just label that V solute. And we'll divide that by 450 milliliters. And then we'll multiply by 100. Okay, so we just need to rearrange a little bit and solve for the volume of the solute. So we could divide both sides by 100, and that will cancel 100 on the right. And then we could also multiply both sides by 450. And that will cancel 450 on the right. So the volume of the solute is equal to 450 milliliters times 8.4 divided by 100. So when I plug that into my calculator, I get, let's see, 37.8 milliliters. Okay, so that tells us that in this solution we have 37.8 milliliters of methanol in solution. So these types of equations can be super handy if, let's say, somebody makes a solution and they only tell you the volume per volume percent, which is 8.4 in this case. And you can see that the total amount of solution is 450 milliliters. So let's say we've just got a bottle of 450 mils of 8.4% solution. And you're trying to figure out, okay, but how much methanol is actually in there? How do I know how much is in there? Well, we can use this equation to figure that out. And we found out that 37.8 milliliters of that solution was methanol. So pretty handy. Now let's look at the last type of percent composition, which is mass per volume. So this is commonly used for IV fluids, and it's defined as the mass in grams of a solute divided by the volume of a solution, but it has to be in milliliters specifically. So notice that milliliters is clearly stated in that equation. So let's do a practice problem. So earlier we said that a normal saline IV solution contains 9 grams of sodium chloride in every liter of solution. So what is the mass per volume percent of normal saline? Okay, so we're given the mass of the solute, which is 9 grams, and then we're given the volume of the solution, which was every liter. So we're going to say 1 liter. But remember, that has to be in milliliters. So how do we convert liters to milliliters? Or rather, how many milliliters are in a liter? A 1,000, right? Milli equals 1,000. Okay, so that was easy. We didn't really have to do a conversion. We just had to know our prefixes. So now let's plug those values into our equation. Okay, so we just need to divide 9 by 1,000 and then multiply by 100. So that should give us 0.9% sodium chloride in solution. So notice if we had not converted our liter to 1,000 milliliters, we would have gotten a completely different answer. So let's just kind of show down below. If we had divided 9 by 1 liter and multiplied by 100, that would have given us 900%. And that doesn't make sense, right? We can't have that much sodium chloride in a solution. So that's why we have to have milliliters in the denominator for this particular equation. Okay, so this video is going to be super quick. In the next video, we're going to talk about molarity, which is more commonly used in chemistry, although you might see the percent composition concentrations in a medical field. But molarity is going to be in units of moles per liter, so we'll talk about that next.